Hello and welcome. Today we're going to talk everything you need to know to start programming in C. We're going to talk about language overview, variables and functions. So let's get started. So C language is mid-level language. What it means that it has high-level specifications and it has low-level specifications. So if I need to explain these levels to you, high level means that it's closer to English, to human language, and low level means that it's closer to machine language. So in that aspect, high-level aspects that C has is loops, conditionals, and functions as any other higher-level language. And at the same time, it has low-level aspects such as managing the memory manually and closely interacting with hardware. So efficiency-wise, it's very efficient. It's very portable. It's compatible with various architectures, being one of the most fundamental and older languages. It has a wide variety of applications such as operating systems, embedded systems, meaning electronic devices, and so on, and performance-critical applications. It's also statically typed. That means that while we are creating variables, the program should already know what type of value that variable is going to save. This typing helps to prevent some basic errors that might happen while running the program in compile time. Now we are going to talk about what compile time means later. So let's go ahead and compare C to more modern languages like Python and JS. So C needs compilation. That's a process we are going to talk about, which is a process before we can run our program. So we need to compile our program before we can run them. Whereas in Python, you can just write the code, save it, and run it right away. And that's called interpreted language. Performance-wise, C is again faster due to their compilation, whereas Python is slower, but easier for prototyping. Memory management, again, as we said in the first slide, C requires manual memory management, while Python and JavaScript, you don't need to worry about it. And Python and JavaScript has many more modern libraries and libraries that does a lot of things compared to C. Now, let me summarize these two slides for you, right? So C is much more fundamental language. This is a language where you want to build everything from ground up so that you can customize everything to get that efficiency gains or to have perfectly relevant solution for your own specific needs. Whereas Python and JavaScript are much faster to prototype and to develop something, but at the end of the day, you are using a lot of the other already existing components from previous programmers. So they both have their advantages. We are focusing on C in this session. So we talked that C needs compilation. So let me show you the compilation process. So I have a chart here. Usually you have header files and you have the code files. Your C programs are going to be in .c files, and that is how your computer knows how to which language of the code it needs to expect. So that suffix or ending, whatever you want to call it, .c ending means that the file saves C program. .h are usually header files. So for now, don't worry about them. Just remember that we have a bunch of code that goes to preprocessor. Preprocessor just reviews the code. It's the macros from .h file. Don't worry about it for now. Then it goes to compiler. Now compiler compiles that code to assembly code. This assembly code goes to assembler. Now assembler code compiles the assembly code to machine code. Now here, the machine can already understand what we have written in the C. Okay, we need to do this process so that machine understand what we have written in C. It does not directly understand C, okay? So now here, all our .c files, meaning all the codes that we have written in different files, compile and now they're machine code, but we need to link them together and make one executable program out of all these small code pieces. And that's what linker does, and now we have executable file. So there are references. The first one, you can go and see what the assembly code looks like and what the machine code look like. And in the second one, this is where I got the flowchart, so I referenced it. Variable types, we're going to talk about the basic variable types, mostly used variable types. So integer is representing all numbers. There are a bunch of types of integers. They vary for two things. First is the size of the number they can hold. And second, if the number they can hold can be positive and negative or only positive. So unsigned versions of all of these means that it can only hold positive values. If you're going to look into it, floating point variables are holding decimal numbers, and it has three types, and those varies for the size of the number they can hold. And characters are things like letters in alphabet or many other that you will get familiar by time, but characters are the characters we know and we use in our daily life. Computer understand that it's character because you have these types. When you create a variable with char type or unsigned char type, it understands that it needs to interpret that as a character. However, every character has numeric representation for computer. Computer does not understand characters. It understands that it needs to interpret that value as number that corresponds to a character. So it's not gonna, we will talk about it more in detail later. Void is nothing type. So if you say void type variable, it should be nothing, right? We will see it in example as well. So integer types, I just listed them here. You can see the memory they occupy in the computer's memory and the range of the values it can hold. Again, the standard short can hold negative and positive values, whereas unsigned short can hold only positive numbers. Now, if you look at them, the short type has 2 bytes, right? It's the same for both of them. And they can save the same variations of numbers. The only difference is that in standard one, half of the memory is used for positive numbers, half of the memory is used for negative numbers, while in unsigned, it's all used in positive. We can also see that as the memory they occupied increases by type, the size of the value they can hold also increases. Let's go ahead and see floating point and char types. So float has 3 types, again 4, 8 bytes and more. And this is the range of values they can hold. There are pretty large numbers with a lot of decimal digits. And there's a new notion here, precision. Now, precision is important because you might think that if you just save, let's say, pi, 3.14 and 20 more characters, 20 more digits, you would think that computer can save it with 100% precision, but that's not correct. Because of the way the computer works and limited memory that each type of variable holds, it cannot save all the digits with 100% accuracy. That's why we have different types and they can hold different number of digits with 100% precision. Now char type. Char types are usually 1 byte, always 1 byte, and standard char can represent 2 characters that corresponds to -128 and 127 for computer, and unsigned chars are representing chars that corresponds to 0 to 255. Now let's talk about chars and see what I mean by that. I know it's a bit confusing because when we look at A, what we see is a character. But when computer looks at A, it sees a number. So by creating a variable as char type, we're already telling the computer to interpret it as number. Or if we just use single quotation marks and character, it would still interpret it as numbers. And we have ASCII table where in this case we have some of the characters and their corresponding numbers. So there are 3 base systems here. You don't need to worry about hex and octal. You can ignore this for now. Decimal is 10 base that we use in daily life. So A corresponds to 65. So when we use character A, computer understands it as 65. Sorry, here. And when we use 1, it understands it as 49. Now it's interesting, isn't it? That's what I was talking about. We are giving it character 1. We are not telling the number 1. And the way the computer knows how to interpret it as character is the single quotation marks. And if we give, and if we are using number 1, it's going to correspond to some other character that I don't even know and I haven't even seen. Right, start of heading. So last but not least, functions. Let's think about some simple mathematical formula that we all know, right? X plus Y, sum. Now imagine an input. What is the input of that formula? X and Y, two numbers. And what's the output? Output is X plus Y, whatever the result of it, right? So something happened in the middle, and then we have the output. So we had the input, we used that input, and we got the output, right? That's called algorithm. It can be simple, it can be difficult, but that's called algorithm. Whatever steps that is executed to take input and to get the desired output is algorithm. Whatever happens in this black box. Let's look at the convention C syntax function. So first we need to mention the type of the return value. As I said, C is statically typed language. That means that every variable you create or every function that you define should present what kind of value to expect from them. So the function is going to return integer in this case, which is whole numbers as we talked. And then there's the name of the function, it's add function, and these between brackets, it is input. So in programming context, it's called parameters or arguments. In this case, we have two parameters, and both of them are integer type. So we are expecting two whole numbers for our function, which is called add, and which is going to return integer value itself. So in curly braces, we have the algorithm. So the steps that we need to execute. And so we create another variable here, it's called sum, and that saves the X plus Y, and then we are returning that function. I have another reference here where I took this visual, but now let's go ahead and do this in practice, and let me share some tips with you. Please follow along if you can, and you should be able to because it's pretty simple and I'm giving all the details that you need. I'm going to go to my terminal and we can continue our session there. So let me clear my terminal. So terminal is a command line interface with your operating system. So what it means is that by writing commands, you can interact with your computer's operating system. Now, I'm not going to go over this. I'm not going to explain a lot of things here. I'm going to do, and you can follow along. Don't worry about it right now. There are much better text editors so that you can use, but you will always need to use terminal. So computer, MacBook, I'm using MacBook, and MacBook comes with a pre-installed terminal. And in Windows, there's some other substitute that I don't know, but it should be very simple to figure it out. Just write, just Google it as a command line interface, and you will figure it out. Okay, so let's go ahead and try to do our exercise. So whenever you open your terminal, it's going to open in the base folder, meaning wherever you have this desktop, documents, downloads, etc. You know where it is, right? Now we'll create another folder for our introduction session, and that's called intro. And then in intro we can go into intro, and then if we list, there's nothing because we just created the folder. Now we are going to create the program. there are a bunch of ways to create the program, which means basically just writing code in some text editor. It doesn't really matter, okay? So I am going to do it using Vim and name of the file. It's going to open a built-in text editor, which is Vim. And then now to insert here, I will need to click I key in my keyboard, and then I can start writing. So I'm gonna write add function. It receives two input, X and Y. And now we need to create another sum variable that's gonna hold X plus Y. And then I need to return that sum variable. Amazing. So everything else you see here, curly braces, semicolons at the end, are just syntax. You just need to get used to it like you got used to writing in English. But it's much simpler, I would say. Now we created our function. We know that it's basically like writing on your notebook that z is equal to x plus y. That's it, right? So it doesn't do anything unless you give value. So in programming context, it is a function. So we have this function, but if I try to compile it right now, it's going to return error because we are not using that function at all. We created it, but we didn't use it. So the expression used when in programming context, when you are using function, it's called calling function. And every program needs a main function to call other functions that it has created inside so that it operates as a whole program, right? One main function and a lot of other pieces connected constitutes a program. Now that's what we are going to do. We are going to create int main function that receives nothing because we are going to give those values inside main. But again, you can also write void here. If you remember, void is nothing. And in parameters section of main function, if we write void, then that means that we don't expect, our main function doesn't expect to receive anything. Now, main function is a bit of an exception in terms of functions syntax or functions features. I will talk about it. I will talk half of it because that's what you need for now. Now let's create another variable sum here so that we can accept the value of the function of whatever this add function returns. So to call the function, I just need to write its name and put the input that I want. And so what is gonna happen, basically, it's gonna sum up and return 4. That is what return means. Return means that it's gonna return some value which you can store or print or use it in some other way. When it is void type return, it's void type, then it's not returning anything. I will tell you about that later. Let's go ahead and then in sum, we are gonna have 4 now. Now, we have 4 here in sum, but actually we are not doing anything with it either, right? So what's gonna happen is gonna be that first function is gonna run. So whenever we give the input, right? Whenever we call, this function is gonna go around, it's gonna return 4, and then that 4 is gonna be saved here. And once this function is also finished running, it's gonna disappear. That value is gone, and we didn't do anything with it. We just saved that value. So what I'm gonna do, I'm gonna print that value. Now don't worry about this printf syntax because it's built-in function. Usually, if I try to do it more manually, there's a totally different way to do this because in C, again, as we said, it's fundamental language and you can build all of this from zero by yourself. And that helps you to understand much more what's going on in the computer. So for now, I'm just going to print that sum so that we know that our add function worked. Now that was how to save it. Escape : W write, Q quit, right? Escape : W Q in Vim to quit and to save and quit. Okay, now we can compile the program and we see some error. What does that mean is that we forgot actually to include the header. So I told you that the printf was a readily available function. Again, we talked about libraries, right? If you want to use existing libraries, you need to import them. And in this case, in C, the syntax to include is import is hash include, and I need to the name of the library, and then again escape colon write and quit, and now I can compile the program. It should compile without problem. Now I will have to have an executable file. Okay, there we go. We can see the executable file. And now I can run this. So to run a program, the syntax is dot and slash internal, and the name of the executable file, not name of the C file we have written, but executable file. If it is not clear, again, just go back and review slides. The compilation process should be very clear once you review it a few times. And now, amazing, we get the sum4. That's what we intended. Now let's go to the file and let me give you a few more tips there. So now let's write a function with a void type, right? Instead of printing it in main, I'm going to create another function called print sum, okay? And that function is going to receive no, sorry. Oh, that function is going to receive to int x and int y, the same function, the same arguments. And what we are gonna do is we are gonna call the sum here instead of in printf, right? We are gonna call add function here instead of printf with the same values. And then we are gonna print it here. So the same thing. The same thing. And I don't need to return anything because it's a void type. Now in the main function, I'm gonna go ahead and delete all of this. And then I'm gonna just call print sum function, okay? I hope it's becoming clear what I'm doing. So now I created another void type function just to demonstrate to you that not all functions are returning something. So in this case, the only mission of this function is to print the sum of these two values that it expects to receive. And it is calling the add function, and at the end it's just printing it. So when we call print sum, we don't have something like int sum equal to print sum, because print sum does only printing, it's not returning any value. So another thing, I told you that main function is kind of special with its ways and with how its return values and parameters work. So in main function, we don't necessarily need to return something. Although we said that it is int type return value, if you paid attention, we compiled and run our program and it runs perfectly without needing to return anything. It is only exception for main function. It does not apply to other functions. If I created this print sum with int return type and didn't return anything, it would return an error. Only in main function, this is the convention. You cannot create main function in other way, at least in the beginning. It should be int main, right? Return time should be int and it should be called main. That's the main function though. Another thing, if you pay attention, I created two same named variables in two different functions. This is not a problem, and let me explain you why. So let's see what happens in the program in higher level, right? Main function runs first. It calls print sum. Now print sum calls print sum with the given values. Now in print sum itself is calling add function with the given values. Add function receives the input and returns 4. Now this 4 goes and is saved in sum, in print sum. And that sum is printed in here, and then it's finished. There's no more. Now, the reason this is the overall process, the reason why these two same named variables are not colliding is that there's a notion called the scope of variable. That means where this variable is still exists or still in power. So this variable is defined in function. It is only available in this function. It's not available outside this function in any other function. And what happens to this variable is that whenever this function is called, it only exists while this function is running. Once it's done running, it ceases to exist. So the same thing happens here. So that is it for this. Let's try to run it. Again, escape and W and Q. You can see it here. This means write and quit in Vim specifically, right? So not all the text editors are same. For now, you can just follow along doing the same things that I'm doing here. Okay, it compiled fine. Perfect. So we are receiving the same results while our code is different. So again, to look at it, we create another void variable and it just prints whatever is the result of add. Now, this is all fine. I hope it's all clear. If it's not clear, please go ahead and review the presentation again. And if you're feeling more comfortable, which you should, if not, please repeat doing the same function until you understand it clearly. It is a bit of getting used to things, so you will get used to it. Don't worry, don't panic. Everyone starts like that. I would like you to do 3 more functions: substitution, division, and multiplication, please. So do all of those simple mathematical expressions in C functions. Take care until the next time.